Welcome back. 7-3, we're just cruising right along here. Multiplication properties of exponents. Let's get it back to the very beginning of the lesson. And you don't need to write anything down from this page. You do need to make sure you have your Know It notebook page 97 and 98 ready to go. So we know that exponential expressions are useful for writing very small or very large numbers, and to perform operations on these numbers you can use those properties of exponents you learned in last year. So it should be a review, and we're going to run through 3 different properties today for multiplying exponents, problems with exponents. Tomorrow we'll work on division. So let's hit it. First though, we got to talk about what does it mean to simplify an exponential expression. So there's a nice box for this right there at the top of page 97, and you're going to need to copy all of these things down. I'll run through them and then you can pause it if you need more time. So it is completely simplified if there are no negative exponents. No negative exponents. Okay. And the same base does not appear more than once in a product or quotient. So for example, this is not simplified, right? We need to combine those a's. And learn how to do that today if you don't already know. No powers are raised to powers, so no parentheses with stuff raised to a power and then another exponent on the outside. Learn how to fix that today too. No products or quotients are raised to powers. Okay, so everything has to be all multiplied out. And lastly, numerical coefficients are simplified or reduced. So we're not going to leave something like this, 10x squared over 5. Okay, we would go ahead and simplify it. Pause it if you need more time to write all these down. I would certainly expect it's going to take you maybe another 30 seconds or so. For the examples and non-examples there at the bottom, you can fill in some or all of these, at least 3 I would say. Examples being things that are completely simplified. So b over a is completely simplified. This kind of matches up. They tried to kind of show you an unsimplified version and a simplified version. So a to the negative second times b times a isn't simplified because we have too many a's that need to be combined. X to the third, that would be simplified. X times x squared, we got to put them all together. Z to the 12th is simplified. That's what you get if you have z to the third raised to the 4th power. So, and if you don't remember that nifty little trick, I bet you might be figuring it out right now. A to the 4th times b to the 4th, that is simplified. A times b all raised to the 4th power is not. And we keep going. Couple more. S to the 5th over t to the 5th, that's fine. You can still have fractions. No negative exponents, remember. And we don't want to leave quotient raised to the 5th power either. So we always want to multiply them out, even if that doesn't really, to you, feel any simpler. To you, these might feel the same, but the rules of math say that this is the one we would keep up top. And simplifying the numbers in the last one. Please write the product of powers property down. There's a nice space there for you with each of the chunks made into nice boxes there, so you can fill those in. The product of 2 powers with the same base. This is really important. It has to be the same base. Equals that base raised to the sum of the exponents. You can abbreviate a little bit, but you need to get that whole thing written down in words in the box there in the middle of page 97. So the product of 2 powers with the same base equals that base raised to the sum of the exponents. And here's a nice numeric example. The base is the same. It's 6 in both cases. And we just add the exponents. 7 plus 4 is 11. So easy cheesy. In general, algebraically, as long as a is a non-zero number and it's real number, then we just add the exponents. Okay, so if it was like x to the 2nd times x to the 4th, it would be x to the 6th. And we'll do a couple more examples on the next page. You can squeeze them either below or maybe in the little margins there. So let's try a couple. First couple here are numeric. Okay. 3 to the 2nd times 3 to the 5th. You don't even have to write this one down. Right? Add it up. 3 to the 7th. Done. And for these, You know, you can probably, on one like that, you can multiply it out or you can leave it. You know, I'm probably not going to have many like this with just numbers. Most of the ones I'm going to give you on tests and quizzes are going to have variables, so you don't have to worry about the evaluation of these big exponents. So don't worry about it too much. This one you might want to jot down. It's a little different because it's got a negative exponent, but the rules don't change. Okay, so we have 2 to the 4th and 2 to the negative 2nd. We add the exponents. 4 plus negative 2 is 2. So we have 2 to the 2nd power. And then we can do the 3's. 3 to the 4th times 3 squared is 3 to the 6th power. You could leave it like that for now. That's fine. If you really wanted to multiply it out, you could. Of course, exponents of 1. You don't need to write that down. All right. Here we go. M times n to the negative 4th times m to the 4th. So you're going to combine all the m's together. Remember, this is m to the 1st. See if you can figure out what it's going to be. And simplifying also means you have to deal with that negative exponent. So what you should have is m to the 5th over n to the 4th power, because we're going to drop that n to the negative 4th down into the denominator so that its exponent can be positive, so it's simplified. I think we have one more of these. Go ahead and jot this one down, pause the video, check, do it yourself, and see what you get. Okay, now that you're back, right, we have x to the 1st and x to the negative 1st. Well, those actually cancel each other out because they add up to 0. So I'm just going to get rid of those. And then x to the negative 3rd times x to the negative 4th, those add together to make x to the negative 7th. And then I need to simplify that. So I get 1 over x to the 7th. You could certainly do it other ways. You could add them all up. You're still going to get 7, negative 7, you then move into the denominator. Next, I thought we were going to move on to a new product, a new property, but we're not. So for this, you're going to need to flip over to page 98, so you've got some space there. This is about multiplying numbers that are in scientific notation already. So this is a little tricky. It's nice to use a calculator for this in general, but it's a good skill to have. So if the light from the sun travels at about 1.86 times 10 to the 5th miles per second, and it takes 15,000 seconds for the light to reach Neptune, then we could actually find about how far it is from the sun to Neptune. We know how fast light travels, that's the rate, and we know the time it takes to get there. So we've got 1.86 times 10 to the 5th for the rate, speed of light, and for the time it takes to get there, they turn 15,000 into 1.5 times 10 to the 4th. To do this, to multiply numbers in scientific notation, I'll squeeze it in over here. Okay. You multiply the front numbers of the scientific notation, and then you multiply the powers of 10, and lastly, you readjust the scientific notation if necessary. So if it's not in scientific notation perfectly anymore, then you go ahead and fix it. I'll show you how to do that. I can't remember if this one works out nicely or not. So the first thing we do is we multiply the front numbers together. So we're going to take 1.86 times 1.5. It's a good time to use a calculator. Let's move that over here. So I have 1.86 times 1.5 is 2.79. And then we have 10 to the 5th times 10 to the 4th. They have the same base, so then I can just add the exponents. So it would be 2.79 times 10 to the 9th kilometers away from the sun. Now, if this front number didn't turn out to be in perfect scientific notation, we could move the decimal either direction and adjust the power of 10. Sometimes we have to do that. It's hard for me to give you well, I guess I could do it. One more quick example over here. I don't really have much space. Hold on, let's see if I can find a blank here for you. Okay, so let's say that the answer turned out to be, here, let's just do an easy one. 5 times 10 to the 3rd times 4 times 10 to the 5th. So we multiply the front numbers and we get 20. We multiply the back numbers, the powers of 10, we get 10 to the 8th. Right? But this isn't in scientific notation because this needs to be a number between 1 and 10. So we go back and we make this 2.0 instead of 20. And now if you think about, before I had to move the decimal 8 places. Well, now I've moved the decimal back 1 place, so now to get back to where I was before, I have to go 1 more place, so it becomes 10 to the 9th power. Right? I was going to have to go 8 places out here, right, to get all my zeros, and now I went back a spot, so I got to go even 1 more spot. So that's how that works if it doesn't turn out to be back in nice scientific notation. Now we get to a new property. Okay. A power of a power property. So when you have a power raised to another power, it equals that base raised to the product of the exponent. So now is when you multiply the products, multiply the exponents. When we multiply powers, we add the exponents. When we raise a power to a power, we multiply the exponents. It's a little tricky to remember. And make sure you get both the numeric and the algebraic versions down. If you need to pause the video for that, you can go ahead and do that. And we have 6 to the 7th times the 4th, all raised to the 4th power, makes 6 to the 28th power. And a to the m power raised to the n power, we just multiply m and n together for the new exponent. In the margin, you can add a few examples in, please. And once again, with the numbers, don't worry too much about simplifying or evaluating that. You can just leave it as a power. So we're just going to take 5 squared, and we multiply the exponents together, and we get 5 to the 8th power. Here we have 3 times 0. Well, 3 times 0 is 0, and anything to the 0 power is 1. Don't get fooled. You try this one on your own. Pause the video, come back. Now that you're back, x to the 3rd raised to the negative 5th, we multiply those. It's fine that it's negative. So we get x to the negative 15th times x to the 4th. And now we're back to the first property. So now the bases are multiplied together. So we're going to add the exponents, and we get negative 15 plus 4 is negative 11. Simplify it so that it has a positive exponent, and you get 1 over x to the 11th power. Woo, hold on, go back. Okay. Last property. Power of a product property. A product raised to a power equals the product of each factor raised to that power. So this kind of feels like, to me, like distributing. Okay? If you think about it, it's not technically distributing, but it feels like it. What we want to do is we basically want to take that 3rd power and we want to distribute it to each of the numbers inside, because if we wrote it out, it would look like this: 2 times 4 times 2 times 4 times 2 times 4. And the commutative property says we can rearrange the multiplication however we want. Associative property says we can group it however we want. So there's no reason why we couldn't write 2 times 2 times 2 times 4 times 4 times 4, which is 2 to the 3rd power times 4 to the 3rd power. So the shortcut way is to distribute it. If it helps you to write it out, then by all means, write it out. Algebraically, a times b raised to the n power equals a to the n times b to the n. And a and b have to be non-zero real numbers. N has to be an integer. Here we go. You should have plenty of space for these because now you're on the back side, anywhere around it. Okay, make sure you got that negative sign out front. And now we're going to take that squared and we're going to distribute it. So we have negative and then 2 squared and y squared. Simplify everything and you get negative 4y squared. Okay, remember, it's the same thing if you just write it out. Negative on the outside and then 2y times 2y makes negative 4y squared. If that helps you, go for it. Same thing here. If it helps you, just write it out. It's fine to take this slightly slower way if it helps you get the right answer. Otherwise, you're going to distribute, and you get negative 2 to the 3rd power, and that negative is with the 2, and y to the third power. Negative 2 to the third power is negative 8. Remember, it's not dropping into the denominator because the exponent is positive. The base being negative doesn't change where the number is, okay? Just the exponent sign. And we get negative 8y to the third power. I think we have one more of these. X to the 6th times y to the negative third, all squared. Pause the video and give this one a try on your own. Now that you're back, you should have either written it out twice so that you could see how to combine things with the earlier properties we've used, just by adding up the exponents, or you're distributing. 6 times 2 is 12. Negative 3 times 2 is negative 6, and then it needs to be simplified. You get the same thing here. 6, 12 x's, negative 3 and negative 3 makes negative 6 y's, and the x to the 12th stays in the numerator, but the y to the 6th isn't very happy there. Negative 6 isn't very happy there, so he's going to go downstairs and become y to the positive 6th power. And we're going to stop there.